Welcome to The Explainer. Now, if you've ever found yourself totally overwhelmed by dense medical jargon, or maybe you've just wondered how doctors actually figure out what's going on inside our bodies, well, you're in the right place. Today, we're going to completely demystify the modern clinical realities of diabetes. And to do that, we're using the official 2026 Standards of Care from the American Diabetes Association. We're going to cut through all that noise and show you exactly how this condition is diagnosed, classified, and understood today.
Okay, let's dive right into this. 1,272. Now, that staggering number, it's not some crazy blood sugar reading, and it's definitely not a statistic about population health. No, that is the exact page count of the 5th edition textbook of diabetes. Just think about that for a second. It literally takes well over 1,000 pages just to summarize what the medical community currently knows about this one single disease. Honestly, it brilliantly illustrates just how incredibly vast, intricate, and, frankly, complex this metabolic disorder actually is.
To tackle this, we're taking a macro to micro journey today. On the agenda, 1. The scope of diabetes, 2. Diagnostic tests and criteria, 3. A1C versus plasma glucose, 4. Classifying the different types, and 5. The stages of type 1.
Section 1. The scope of diabetes.
To really understand this condition, we have to completely shatter the common perception that diabetes is just a simple issue of high blood sugar. This massive 5th edition textbook of diabetes really visually grounds us in the sheer volume of medical knowledge required to truly grasp this disorder. Because diabetes mellitus isn't just one thing, right? It's actually a whole group of metabolic disorders where glucose is either underutilized or overproduced. And the ripple effects of that one core issue, they impact virtually every single system in the human body.
I mean, just look at some of these actual chapter titles. We aren't just talking about insulin here. We're talking about the microbiome in diabetes. We're looking at bone and rheumatic disorders, end-of-life care, and even the incredibly complex relationship between diabetes and cancer. It's absolutely crucial to realize that this is a deeply complex, multi-system condition. But you know, despite this massive scope, a doctor sitting in a clinic still has to actually find a practical way to test for it.
Section 2. Diagnostic tests and criteria.
So, how do medical professionals take this massive 1,272-page scope of knowledge and boil it down to actionable diagnostic rules? Well, the crucial point here is the numbers. What we're looking at are the clear-cut 2026 American Diabetes Association diagnostic criteria. These are the exact thresholds you or a family member might actually encounter at a routine checkup. First up, you have the A1C test, where a result of 6.5% or higher indicates diabetes. Then you've got fasting plasma glucose, where 126 milligrams per deciliter or higher triggers a diagnosis, provided you fasted for at least 8 hours. There's also the 2-hour plasma glucose test, which is done during an oral glucose tolerance test, with a threshold of 200 or higher. And finally, a random plasma glucose test of 200 or higher. But, and this is key, this last one is only diagnostic if the patient is also experiencing classic symptoms of high blood sugar. You know, things like unexplained weight loss or excessive thirst. Now, what's really important to take away from all this is that unless a patient is in the clear crisis, a diagnosis absolutely requires confirmatory testing. That means either 2 abnormal results from different tests done at the exact same time, or the same test repeated at a different time.
Section 3. A1C versus plasma glucose.
So, we just saw the 2 primary clinical avenues for diagnosis, testing A1C or testing plasma glucose, and they offer completely different ways of looking at the same problem. Think of A1C as your chronic perspective. It measures glucose bound to your red blood cells over their entire lifespan, which is about 120 days. So this gives doctors a weighted average of your blood sugar over the past 2 to 3 months. It's incredibly convenient for sure, mostly because it doesn't require you to fast, and it doesn't get thrown off if you're super stressed or, say, just ate a huge meal. Plasma glucose, on the flip side, is an acute measure. It tells you exactly what's happening in your blood right at that very second. But it has really high within-person variability. It requires a strict 8-hour fast, and there's this real issue called glycolysis. Basically, blood cells actually continue to consume glucose while sitting in the sample tube. That means if the blood sample isn't processed properly by the lab, the glucose concentrations will literally show up falsely low. Crazy, right? So both tests are absolutely crucial, but they tell the doctor slightly different stories.
Section 4. Classifying the different types.
Let's say those tests come back positive, and the diagnosis of diabetes is confirmed. You might think the whole process is over, right? Well, actually, a real medical mystery is just beginning. Is it type 1 or type 2? For decades, we honestly had a very simple and very flawed paradigm. People just thought type 1 diabetes was strictly for kids and type 2 diabetes was strictly for adults. Well, the 2026 Standards of Care throw that outdated idea completely out the window. Both diseases occur in all age groups. In fact, and this is a huge clinical reality, up to 40% of adults with new onset type 1 diabetes are initially misdiagnosed. They're often just assumed to have type 2 simply because of their age.
And this brilliantly illustrates how doctors actually solve this mystery today. What you're seeing is the actual flowchart used for investigating suspected type 1 diabetes in newly diagnosed adults. It's definitely not just guesswork anymore. When the classification is unclear, doctors rely on specific biochemical markers. First, they test for C-peptide, which is basically a byproduct that shows if the body is still producing its own insulin. And they test for islet autoantibodies, things like GAD, IA2, and zinc transporter 8. You see, type 1 is fundamentally an autoimmune disease where the body actually attacks and destroys its own beta cells. So finding those autoantibodies, that's the smoking gun that points directly to type 1, regardless of how old the patient is or what they look like.
Section 5. The stages of type 1. Thanks to those biochemical markers we just talked about, we can now zoom all the way to the microscopic, cutting-edge details of how type 1 diabetes actually develops. Let's move to and see how this builds, because this is where modern medicine is truly astounding. We no longer wait for someone to end up in the ER to say they have type 1 diabetes. We now understand it happens in 3 very distinct stages. In stage 1, a person has totally normal blood sugar, normal glycemia, and absolutely 0 symptoms. But if you ran a blood test, it would reveal the persistent presence of multiple autoantibodies. The autoimmune attack has already silently begun. Then, in stage 2, those antibodies are still there, but now we start to see dysglycemia. The blood sugar is beginning to become abnormal, even though the person still feels completely fine. Finally, we reach stage 3, which is overt hyperglycemia. This is when those classic symptoms finally appear, and a traditional clinical diagnosis is made. The main takeaway here? By screening for those autoantibodies, science can now detect the disease literally years before the symptoms even show up.
And that brings us to a really provocative thought from the 2026 Standards of Care. We've seen just how wildly complex this condition is, and how those old rules of type 1 for kids, type 2 for adults are completely dead. While the source material notes that ongoing research is actively combining genetic, pathophysiological, and clinical characteristics to further define entirely new subsets of this disease. So here's the question. As our understanding deepens, will the broad label of diabetes soon just disappear entirely? Will it be replaced by dozens of highly personalized, distinct diagnoses tailored to an individual's exact genetic makeup? It really forces us to reconsider everything we thought we knew about this 1,272-page disease. Thank you so much for joining me on this explainer today, and I really hope this structured look at the modern clinical realities has empowered you with a completely fresh understanding of the topic.